Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Austin who has just completed the course Linux Basics for Robotics and will be giving us a presentation on that. So as we always do, we are going to begin by seeing his code base running on the robot, and then we can then get into the details, get to ask him a couple of questions so that we understand what did he do to make the robot behave in such a way. Alright, I will hand over the platform to you so that he can begin his presentation. Okay, Austin,
Okay.
whenever you're ready.
Hello, everyone. I will start my presentation.
Alright.
Okay. So basically, my outline will cover the project overview, what the project I did, what is the beginning, what is included inside, and the second will basically go through the program, what I wrote, and also the script, also the things I encountered, and also the resolutions and the real-time demo. So basically, the entire project I divide like to four parts. So the first thing is very basic, is the very basic script. And this script is like the program writing the bash, notify the robot's behavior logic. So it define the move and stop and turn and basic other sensor readings. Yes, and the next will also include in the second part is the robot function. And this part is the the setter function handle the communication with the ROS2 parameters. And this is like a bridge. You can communication between the logic and ROS2. And the go on is the ROS2 parameters. This part is basically focused on the real-time variables for the robot system, for the speed and angle and distance, and this scan data. So that we can real-time know how was the value and how was reading from the runtime. And the last thing is for example, of course, is the simulate and the real life robot the implementation. So the last part is focused on the executed commands received for the RS2.
Yeah,
And
don't forget you
so
need to show the real demonstration, right? So,
oh
yeah, so
yes, maybe I just around.
yeah,
Yes,
so that you don't run out
and
of time, right? You
we
can
can
always explain a lot more after you show it running. Okay.
yes. So we can see the now robot is keep going because don't see any block inside of him. And then you see now he encounters some blocking on the left side, so he turn right. Yes. And after set successfully, and then he will keep looking, okay, now it's very clear. So now it is safe, so we can move forward. After move forward, we stop and do searching and scanning screen again to see maybe it's too closer to the block or is it safe. Now you see the right side is very dangerous, so you will connect and then we can save and then move a bit. Yes, and we can see a couple seconds, and then you can see it's left side is a block, so now it's time to turn right. Yeah, so this is the loop. We'll keep looking for which part is a block and which part is safe, and then we keep move forward. Yes.
All
Okay,
right.
so basically the program is very simple. We just see on the lot of direction threshold, and we'll see which side is blocked. If this side is blocked, we'll go to the other safe side block. Yeah, so corresponding to the code, here is the I observators. And first of all, we'll see the first case. Yeah, the first case is like very easy to understand. It's always blocked.
Yeah, okay.
So the
Can you make
robot
that one a bit bigger? So just leave the one screen, one robot camera view,
one official
and then
maybe
no,
that
no,
would be better.
no. Just move it to the right a little bit so that we can see the robot as you explain what you're doing. So,
Okay, so
yeah, a bit
I need
more.
to bit more.
No, to the right.
More.
To the right.
Oh, okay, sorry.
Yeah, because we have to see the robot. Yeah, then you can
Okay,
drag it down
maybe
and
it's
it's
better.
easier to see what you're talking about. Yeah.
Okay, now it's okay.
Yeah, it's alright.
Okay,
It's
uh,
workable. Yeah.
okay. Okay, so the first is the way is blocked. So this is before is because always blocked, so needed to decide like the maybe which side is more better, left or right. And
Mm.
before he determined this logic, I will implement to let the robot move a little bit because sometimes I think the robot will be if the left side and right side is the same, not easy to let him to understand which side to go.
Mm.
So I move a very little bit, maybe it will be more easy to the robot to think about left or right side. So yes, so when you go a bit more and stop, and then you can see the left side is better, the left side, right side is better than the right side,
Mm-hmm.
and it's very easy to understand. And the go on is the divide to the sorry, better. And the second case is based on is you can see here the left side is not free and the front is not free, so definitely need to go to right. So we just go to right, and then the next one is the left is blocked or the right is blocked. So the only choice you can do is just need to go ahead. Yeah, that's all. And the go ahead, I don't do too much distance. I very bit because I'm afraid you will hit the wall or go ahead too much. And the go on is the very easy to see. You can see the front left is blocked, but the front is clear or
Mm.
the front left is free. So it's better to go to the right. So to
Okay.
go to the right.
Okay.
And then the go on also same the logic, just depends. Now we go to the right.
Mm-hmm.
The block is on the right. Yeah, yeah. And this one is also same. Yeah, it's also based on the design direction turn. So yes, I think the rest also same. The block is on right to the left. And the last thing is important is everything is clear. It's also move forward. And I also don't put too much distance because I'm very afraid don't go too far away
Okay.
to for safety. Yeah, yeah,
Okay.
yeah.
What threshold are you using? So I saw that it got pretty close when it was in the top left corner, right? So what's the threshold?
Yes. The threshold is here.
Okay, 0.3. Okay. All right.
Yeah,
All right.
yeah, okay, yes.
And
Okay.
so you are processing how many sectors?
Seven, eight case. Yeah,
Eight.
eight
Okay.
case.
Okay. Eight
Yeah,
cases.
yeah,
All right.
yeah, yeah. Okay. So you can see the left side now is I would say turn. I'm sorry, maybe here. Yeah. So now you see it's going to turn right.
Mm-hmm.
Yes. Now turn left. Move forward. Yes.
Okay. Okay. I see.
Okay. Okay. So I go back to the presentation, and this one is is the live data. Yeah. So it is the display the yeah local display. Yeah. So basically, just carry the real time data, so then we can see the real time data, and then we can understand what is robot reading, and how we can see the feedback. Yeah, basically just like the open positions and the orientations, and then also including the IMU, and also like the linear accurations
Mm-hmm.
to see what's the robot feedback. Yeah, basically that is fundamentals and robot
Did you get
feedback.
any IMU data?
Yes.
Uh, how did you get
For
that?
IMU, I get the angular velocities and the linear acceleration. Yeah, over here.
How did you get that? Because this robot doesn't have an IMU, so I want to know.
I just write in functions.
Okay, okay, and
Yeah. You have this one. Yeah,
okay, I see.
yeah. I define over here.
And so let's look closely at what's going on there. So okay. Can you scroll to the side in a bit?
Straight right.
Rosparom dot. Okay, just make it full screen. It will make it easier.
Uh,
UIDE, yeah. The IDE, Austin. The IDE. So press the green
uh,
dot on the top. The IDE, not the robot screen.
okay. Oh, okay.
On the top, just below disconnect robot. Yeah.
Disconnect robot.
Mm-hmm. That's the one I want to see. Yes. Okay, I see. Oh, now, okay. Are you doing something or is it disconnecting automatically?
No, this.
Because right now you're disconnected, but you should be having 7 more minutes. So reconnect and let's see.
Reconnect?
Yeah.
Okay. Okay, maybe so okay. Cool.
Okay, alright. So just move it out of that place so that it starts moving normally. So can you still up or the job at?
Okay. Maybe this part. Cool. Yeah, yes.
Alright, so let's run the obstacle reader again. Then you can run your base script, your statistics base script. That's the one I want to see. So
Okay.
okay.
Oh, it's not. It's not really that.
Okay, IMU acceleration, you get no values. Alright, I see. Yep. Alright, that's good. You can terminate. Yeah, so I wanted to see
Oh,
those
okay.
values to understand
Uh,
if you're getting any, where you're getting them. So,
yes.
alright, so,
Okay, maybe
okay, yeah, you can
as the
continue
last.
and then, yeah.
Yeah. We basically because it's run out of the time, so
Hmm.
very soon. Okay, so this is kind of the challenging I encounter, also some solutions.
Mm-hmm.
So the first is the series difference. The very for me the see it because the first time I do it through the simulation error, but I found the doing the simulation turned very well, but the robot I think I don't know why it cannot turn well. So I find it's the error is difference, and the
Hmm.
robot cannot turn correctly in the yeah when doing the real robot. And this method is good because the maybe I think it's like the real world physical construction have strong influence like the well ground friction or the insufficient motor torque or the higher mechanical inertia or because the railway is very difficult to turn. So
Mm-hmm.
I slightly increase the angle to 0.1 to 0.7 and then can turn very successfully.
Okay.
And the second is the I found the robot will be keep continue to rotation itself.
Mm-hmm.
And I found out it's because the command before I didn't set the sleep to let it stop, so you will be receiving the signature.
Okay.
So yeah, it was clear and to yeah. And the last one is the assessment for the version you will have to first so then you can go forward. And
Mm.
then
I think you have
mention
to
yeah
repeat that,
myself.
Austin. Your sound is getting a bit chopped up. So let's go back to that in slide number 11. Slide number 11. So that one. Yes. Can you explain a bit more what you're saying there? Yeah, because your sound
sure.
was
Because the first time I didn't set to 0.0 and I set and I found the robot will receive this command and will keep turning the 0.7 angle and once again double point again. So I say the command, make sure they only turn once, just a 0.7 angles and then stop. And then don't do any further, just wait for the other script to do the next further actions.
And did this work for you in, like, was this as close to real time as possible?
Yes. So in the real time, I also do my here. So yes. So when the O block.
Okay, so tell me one thing. So you chose sleep 1. What did you try any other values? If you go
no,
sleep
I just
2,
basically just sleep once. Yeah.
Okay, if you had changed that, how would that make any? What would be the effect on your control mechanism?
I think for here will not be quite different.
Why do you say that?
Will not. Yeah, because for the most important thing, for my opinion, is like we just need to make sure you need to clear the last command for, otherwise if they keep receiving the same command, maybe we're not to like itself to stop and wait the further.
Okay,
command.
So
yes.
Okay, I think for us to really get to the bottom of this, you added a sleep after setting the value, right? After setting the maybe angular velocity to a particular value or linear velocity to a particular value, you added a sleep. Why did you do that? This is the foundation of the question, right?
Actually, I just want to make the safe between two commands. Yes.
Yeah, but then you have to think about it more deeply than that, right? If you keep setting that parameter to that value, or if you don't sleep, what was the effect? Did you try it in a different way and you saw that it didn't work?
That's a good suggestion. Yes, maybe if the time without sleep or with the sleep perhaps could be the same. Could be the same result. Yeah.
So how did you come to the conclusion that I have to add a sleep after setting a parameter?
I'm just thinking because I just want to make sure that command is executed successfully and let the robot can have the buffer between the two commands. Yeah, I want to, because usually I do the more set design. So the first time I think is two commands definitely should be wait, because if the latency or the command are,
I would say
more execute more longer time.
Yeah. Okay, so I would say yes and no, right? Because let's think about it a bit. If your robot is going to go forward by a particular distance, what is the best way of controlling the distance it covers, right? In this basic base scripting, how would you do it? Let's say it's a general term, you didn't have any knowledge about base scripting, you just want to make your base script run the robot for 5 meters, for 1 meter, for how would you control that? How would you control the distance that the robot goes for?
How do you control the robot distance? I didn't follow the questions.
Okay, so I'm saying, given that you have a robot that has got everything programmed for you, all that you're supposed to do is to create a base script that tells it to go forward for 10 meters or 2 meters or 5 meters. What's the best control parameter that you can use to determine the distance covered by the robot?
Covered by the robots.
Yeah, given what you know about bash, right? We're talking about bash scripting, so I'm saying if you're going to write a bash script that controls the distance the robot moves forwards and backwards, how would you control that distance?
Oh,
Hmm.
control this. You mean how do I decide if the this time go 10 and next time go 20 and when do we go to 30? Is
How
this question?
my question is how do you how do you determine what distance it goes for, or how do you determine the distance covered?
Mm,
Because obviously you have the capability of setting command velocity, you have the capability of setting linear velocity, right?
mm-hmm.
But you have to control the amount of distance that the robot covers at that particular speed, right? If you want to regulate um, the distance it covers, you have to think about it in a broader spec. This is the question that I'm trying to ask you without giving you too much.
It's okay. It's a good question for me to thinking more further. Yes.
All right, so I'll tell you what I'm expecting from you. So the reason why you said sleep
Uh,
time to 1, right? Once you set a velocity of zero point 0.1 meters per second, you know that in at zero point 0.1 meters per second, your robot is gonna go for 1 second and stop, right? Because you make it sleeps for 1 sec, right? And then you set it to a different
yes.
value after that second, right? So if you set it to an angular velocity that is to some angular velocity, if initially you had set it as a linear velocity, it's gonna go forward or whichever backwards for 1 second, and then you reset that value to a different one, or you set it
Mm-hmm.
to 0 and then set angular velocity to another value, which means the robot is gonna turn when it gets there, right? But on the basis of how long you call sleep, so in your code you're saying sleep 1, which means it's gonna sleep for a second. If you go sleep 10, then it's gonna sleep for 10 seconds, right? So on that basis, you know that if I set my velocity to zero point 0.1, then times 10, you're gonna go for 1 meter each, right, in quotes. So uh, that's what I was trying to get from you to say
Mm-hmm.
that sleep that you put after you set command your velocity is to control how far the robot goes for. But yeah, it didn't come out that way, but no worries, no worries. Okay, anything else
Okay.
that
Okay.
you wanna say? Or
Yeah.
the,
I think my presentation, yeah, is all questions. Yeah. All slide is introduced. Yes.
all right. So thank you very much for
Yes.
your
Yeah.
presentation, Austin. So just hang around, and then we'll continue the conversation later.
Thank you so much. Thank you.
All right. Thank you, Austin. All right, everyone.
Thank
This
you.
was
Thank you.
Austin's presentation, and I would like to thank him for coming to make a presentation, a wonderful one. And I'd like to encourage all those of you who would want to try this course or any other one that we offer certification on to go onto our platform, and then you can attempt the courses there, and then you get to do the final project. This is the one that you have to showcase live, just like